Okay, 6.4, transformations of exponential and logarithmic functions. So these are our parent graphs for exponential functions. This one's going to be exponential growth because the base is more than 1. And this one's going to be decay because the base is less than 1. So the general shape of this one will be kind of an uphill curve, and I'll get a downhill curve for the decay. Okay, so on both of these parent graphs, they're going to have, well, any exponential function is going to have a horizontal asymptote, and for the parent graphs, that horizontal asymptote is going to be on the x-axis like that. Okay, so we can plug in some different x values. If you plug in 1 for x, well, 2 to the first is 2. So the point 1, 2 would be on the graph. And then 2, 4 would be on the graph as well, right? Because if x equals 2, 2 to the second is 4. If you plug in 0 for x, 2 to the 0th is 1. And if you plug in negative 1, well, 2 to the negative first is 1 over 2 to the first, so 1/2. Okay, I'm going through this kind of quickly because I showed these parent graphs in a previous section, so I don't want to spend a ton of time on the parent graphs. I want to spend more time on the transformations to the parent graphs, but that's what that one's going to look like. If you make an XY table, this will also have a y-intercept of 1, and it's going to be kind of a mirror image of this one. So it'll look something like this. Okay, and then on both of these, the curve is going to approach the asymptote at the ends. Okay. All right, so there's our parent graphs. So let's start messing with these equations and see what happens. Okay, so on this next example down here, I've got y equals 2 to the x plus 3. So let's try plugging in some different x values. Well, let's see. Let's make an xy table here. If I plug in, let's plug in 0 for x. Well, then I've got 2 to the 0th. So y would equal 2 to the 0th plus 3. 2 to the 0th is 1. So then y would equal 4 when x equals 0. Okay. And then I'm not going to write out the equation for all these, but let's just think through them. If I plug in a 1 for x, 2 to the first, so that'd be 2 plus 3. I get this. Okay. If I plug in 2, I've got 2 to the second plus 3, so that's 4 plus 3 is 7. Okay, let's try some negative numbers. I'll plug in negative 1, so that's going to give me 1/2 plus 3, so 3.5. And then if I plug in negative 2, I'm going to get 1/4 plus 3, so 3.25. Okay, so let's plot these. So I got 0, 4, 1, 2, 3, 4. 1, 5, 2, 7, negative 1, 3.5, and negative 2, 3.25. So we can see we've still got exponential growth because our base is more than 1, and you can see where the curve is going now. Maybe you can even see where the horizontal asymptote is going to be. It's going to be right here. Okay? And if you look at the equation, that's going to correspond to this number. So when you're adding or subtracting something to the end of your exponential function, that's just going to move that horizontal asymptote up or down. Okay, so it's really just this graph everything's moved up 3 units. Okay, so this would be the line y equals 3. Okay, so for your horizontal asymptote, you can just take y equals whatever is added to the end. And then I should draw in my curve here. Okay. All right, so the horizontal asymptote is not always on the x-axis. It can move around, okay? So looking at this next example, I'm seeing this and thinking, oh, my horizontal asymptote is going to be y equals negative 5. So 1, 2, 3, 4, 5. So there's going to be a horizontal line at the very bottom of the horizontal asymptote at the very bottom of that provided graph there, okay? All right, so I'm looking at this again, and I'm looking for the base, and I see that the base is more than 1. So I'm going to have a growth curve. So my general shape is going to be something like that. And what I want to do is find a couple of points so that I can I know it's going to kind of go uphill, but let's get a couple of points to guide our curve. So the 2 points that I usually use are the intercepts, okay? Now this equation didn't have an x-intercept, but this one should have one because it's going to go like that. So it should have an x-intercept and a y-intercept. So let's go ahead and find both of those. So if I want the x-intercept, I'm going to plug in 0 for y. If you try to find the x-intercept on this graph, you're just going to, it's going to be undefined if you do it algebraically. So I've got 0 equals 3 times 2 to the x minus 5, okay? And I want to solve this for x, so let's try to get x by itself, and we'll do as much as we can with adding, subtracting, multiplying, and dividing. So first thing you'd want to do is add 5 to both sides. Now I've got 5 equals 3 times 2 to the x, okay? And then don't, what I see often is people simplify this, say, oh, that's going to be 6 to the x. Well, no, it's not, because the 3 is raised to the first power and the 2 is raised to the x. So you don't do the multiplication there because of PEMDAS, okay? But we can get rid of the 3 just by dividing both sides by 3. And those will cancel then, right? So now I've got 5/3 equals 2 to the x, okay? Now I can't do anything else with adding, subtracting, multiplying, or dividing to get x by itself, but I can put this in log form, okay? Because log form is going to isolate the exponent. That's what I want to happen, because I want to figure out what x equals here, okay? So log form, my base is 2, so that's that little footnote there, okay? The exponent gets isolated, and then the 5/3 is going to go inside the log. That's going to be the contents of my log, or the argument, okay? And now I have something that I can put into my calculator. In my calculator, I'm going to have to write this as, my calculator, I can't change the base. I can only do natural base or base 10. So I'm going to change this to base 10 using the change of base formula. So the 5/3 is higher up than the 2. That's how I remember a log of 5/3 goes in the numerator, okay? And then let's see, I got log of 5/3, okay? I'm going to close the parentheses on that, and then I'm going to divide by log of 2, and I've got this decimal. So x is going to be about 0.74. Okay. All right, so 0.74 is my x-intercept. I can't do that accurately, but somewhere in there, right? About 3/4 of the way over to 1. All right, and let's find the y-intercept. So that was all for the x-intercept there. Let's find the y-intercept. I'm going to plug in 0 for x, and this is going to be a little easier than the x-intercept. Okay, so I'm going to just start with this piece, because anything to the 0th power equals 1, so that means I've got 3 times 1 minus 5. Well, that's just 3 minus 5, and that is -2. So my y-intercept is -2, and then it is going to fit with a growth curve shape, right? So I'm just going to make a curve that goes through those 2 points, and also I'm going to use the asymptote as a guide. And you could find more points if you wanted to get even more accurate with your curve, but that's a pretty decent graph right there. Okay. Okay, so the -5 moves everything down 5 units. What the 3 does is it makes your curve a little bit steeper, right? If I had 4, it'd be even steeper. If I had a 7, it'd be steeper than that, and so forth, right? And if you have a coefficient that's less than 1, then it'll make it less steep. Okay. All right, but you can figure that out just by finding the intercepts. All right, so let's look what happens when we're adding and subtracting something. This isn't adding and subtracting inside the, it isn't adding and subtracting to the end of the equation. It's adding and subtracting to the x that's in the exponent, okay? So what this did is move things down. If you're adding and subtracting inside the exponent, it's actually going to move things left or right, okay? So this transformation, what this is going to do is actually move things to the right. It's kind of like when you're finding the x-coordinate of the vertex of a parabola. So if you set this equal to 0, then I get x equals +1 if I solve for x. So this is going to move everything 1 unit to the right from the parent graph, okay? But you don't, for me, I just find the asymptote, and then I find the x and y intercepts, at least if they exist, and then I just make my graph from that. Okay, so yes, this is shifting things one right, but that's a little bit hard to visualize from the parent graph. I do know I have a growth curve here, so this is going to be going uphill from left to right. Okay, and then there's nothing added to the end here, so I could write that as plus 0, and that means my horizontal asymptote is going to be the line y equals 0. Well, y equals 0 is the x-axis, right? So there's my horizontal asymptote. Okay. So since I was just moving this left and right from the parent graph, that didn't change the position of the horizontal asymptote. Okay. And then let's find some intercepts. Now I'm not going to bother with the x-intercept because I can't have a line on the x-axis because there's an asymptote right there. Okay. It's going to be undefined if you try to find it. You'd have to plug in 0 for y, and you're just not going to be able to find an x value that you could put it here and have y equals 0. It just doesn't exist. Okay, but we can find the y-intercept. So let's go ahead and do that. My y-intercept, I'm going to plug in 0 for x. Okay, so I've got y equals 2 to the negative first. Oops, that's off screen there a little bit. All right, and when you have a negative exponent, you can write that as a fraction with a positive exponent like so. So that would be 1/2. So my y-intercept is 1/2. Okay, and I could find another point by plugging in another, I could plug in 1 for x or 2 for x. Actually, let's go ahead and do that. When I plug in 1 for x, I've got 2 to the 0th. So the point 1, 1 is on my graph. And now I've got a pretty good idea of what this is going to look like. And again, you could plug in more points. But I've got a growth curve looking something like that. Okay? So since I've shifted everything to the right, that means my y-intercept is lower than the parent graph because, 1 was my y-intercept for the parent graph. If you took this whole thing and shifted it left 1, then the y-intercept would be 1, at positive 1 there, right? Okay. So two things are going to happen on this next curve. Everything is going to be moved left 3 units, and then everything is going to be moved down 4 units. Those are the transformations from the parent graph. Okay, but let's go ahead and graph this. This is going to give me my horizontal asymptote. So that's going to be y equals -4. So let's go ahead and put that in. That's clear at the bottom of the graph there. Okay, and I've got growth here again because my base is more than 1. Okay, so that's my general shape. All right, and let's find some intercepts. This should have an x-intercept and a y-intercept. So let's see what happens. So my x-intercept, I'm going to plug in 0 for y. And this one always takes a little bit more work than the y-intercept because ultimately I'm going to have to put this in log form to solve it, to get the x out of the exponent. Okay, but before you do that, isolate x as much as you can with addition, subtraction, multiplication, or division. And I can add 4 to both sides here. Okay. Okay, sometimes I see people divide by 2 to try to get rid of the 2 there, but that doesn't work because we've got 2 raised to this power. Okay, so there's nothing else we can do with addition, subtraction, multiplication, or division. We have to put this in log form. So my base is 2. The exponent is going to get isolated. That's the x plus 3. Okay, and then the 4 is going to become the contents of the log. Okay, so you could subtract 3 from both sides now if you wanted to, but you'd have this whole value minus 3. So this would not become log base 2 of 1 if you subtracted 3 from both sides, because the -3 would be outside of the log. Okay, so I'm going to just simplify this first. So you can use a calculator. I put that in as log 4 over log of 2 using change of base. But 2 raised to some power equals 4. Well, that should come out to 2, that part I circled. So let's see if that works. Log of 4 divided by log of 2 comes out to 2. Okay, so 2 equals x plus 3. Now I'm going to subtract 3 from both sides. And I've got -1 is equal to the x. Okay, So there's my x-intercept. Okay, let's put that in the graph. And let's find the y-intercept. Here, let me separate this a little bit. Okay, y-intercept, plugging in 0 for x. Okay, so that's just going to be 2 to the third. 2 to the third is 8. 2 times 2 times 2. So my y-intercept is going to be 4. Got just enough space for that. And I've got a growth curve using all this info I have. So something like this. And again, you could find more xy pairs if you wanted to get an even more accurate graph. Okay. All right, let's try some more. Hey, we got some log functions. So these exponential functions that I just did have a horizontal asymptote. But if you remember, log functions are going to have vertical asymptotes, okay? So these are actually my parent graphs for log functions. I think I'm getting ready for some transformations to log functions on the next page. So these ones are both going to have vertical asymptotes on the y-axis, like so. Okay, and I still think of this as growth because I've got a base that's more than 1. So that means it's going to be going uphill from left to right. It's going to do something like that for a log function, but it's still going uphill if you think of it from left to right. And then this one is going to be decay. The base is less than 1, and it's going to look something like that, okay? These are both going to have the same x-intercept, so I'm not going to go through solving for those, but you could just plug in 0 for y and solve. So they're going to have an x-intercept at 1, okay? So this one's going to look something like this, and this one's going to look something like that, okay? All right. So just to get those parent graphs on there a little quickly so we can move on to the transformations. And I did these in a previous section too if you want to look at the parent graphs more closely. Okay, so let's look at some transformations. So the transformations are actually going to work pretty similarly to the transformations with exponential functions. So this, if you have something added or subtracted to the end, that's going to move things up or down. In this case, it's going to move everything up 1 unit. It's going to be a translation up 1 unit. Okay? This is going to move things left or right. In this case, it's going to move it left. Okay? So if you take this and set it equal to 0, and then solve for x, I've got x equals -3. Negative would mean to the left on the x-axis, so that means this is going to go left 3. Okay? Now, knowing that this one's going to be growth because my base is more than 1, so the general shape is like the parent graph I've got above there. Okay, so these are going to have this is going to have a vertical asymptote. Okay, moving that vertical asymptote up or down. If I'm moving this up 1 unit, it's not going to change the position of it, but the left-right will, right? So the left-right is actually kind of more important for your graph because it's going to determine where the horizontal asymptote is. Okay, and your horizontal asymptote is going to be this equation. This is going to be the horizontal asymptote. Okay, so you just take the contents of the log, the argument, set it equal to 0, and solve for x. And vertical lines would be x equals something, right? In this case, I've got x equals -3. So let's put that in the graph. There's my asymptote, and that's going to serve as a guide for my curve, right? So my curve is going to come and hug that line, okay? Let's find some the x and y intercepts. So x-intercept, I'm plugging in 0 for y. Okay, so I want to try to get x by itself. Again, use addition, subtraction, multiplication, division as much as you can to begin with. And I can start by subtracting 1 from both sides. Now I've got -1 equals log base 2 of x plus 3. Okay, some people now are going to subtract 3 from both sides, but you can't do that because this 3 is trapped inside of the log right now. Okay, so in order to get the x plus 3 out of the log, I have to convert this to exponential form. Okay, so 2 would be my base. In log form, the exponent is isolated, so this is my negative 1 goes there, and then that's going to equal the quantity x plus 3. Okay, so 2 to the negative first, that's 1 over 2 to the first, so 1/2. Okay, and now I'm going to subtract 3 from both sides. So I've got, 0.5 minus 3, that would be negative 2.5 or negative 2.5. Okay, so let's see if that fits in. Negative 2.5 is my x-intercept. There it is. Okay, let's find a y-intercept. So I'm expecting, since I have this space, this shape, that my y-intercept is going to be somewhere up here, right, above the x-axis. If it's down here, then it would look like decay. So let's see what happens here. Let's find the y-intercept by plugging in 0 for x. Okay, so I can write the log as just log base 2 of 3. Okay, don't combine those into 4. The 3's inside the log, the 1 isn't. So you'd want to use a calculator. 2 raised to some power equals 3. It's going to be 1 point something, but let's use a calculator to get a good approximation there. Log of 3 over log of 2. I'm using change of base there. So that's going to, like I said, 1 point something, so it's going to be about 1.58. And then I add 1 to that, 2.58. Okay, 2.58, somewhere around there. And hey, it is going to work with making a shape like that with those 2 points. So, as you go down, the curve will get closer and closer to the horizontal asymptote, but never touch it. Okay. All right, last one. Let's try this one. Hey, this is going to be a decay curve because I've got a number less than 1. So the general shape, instead of going uphill, I'm going to be going downhill, something like this. Okay, and I'm going to have some sort of a vertical asymptote. Oh, you know what? I said horizontal asymptote. I meant vertical asymptote on the previous problem. So let's fix that. I did all the work right. I just called it a horizontal asymptote, and it should have been a vertical one. Okay, so, all right, so let's take a look at this one. Let's find that asymptote to begin with. So I'm going to take this to get my vertical asymptote. Okay, so x plus 4 equals 0, and then x equals negative 4. So, okay, that's moved everything left 4, right? This is going to move everything up 3, but we can just find the x and y intercepts to take care of that, okay? So x-intercept is always going to take a little bit more work. So plugging in 0 for y. I'm going to solve this for x, so I'll start by subtracting 3 from both sides. Okay, and then I'm going to have to put this in exponential form. That's my only option now. So base is 0.5. I'm going to be raising that to the negative third, and this all equals x plus 4. Okay, I'm going to put this into my calculator, and after I get a decimal there, then I'll subtract x from both sides. So let's see. I've got 0.5 raised to the negative third is 8. Okay, and then subtract 4 from that. And then 4 is my x-intercept. Okay, let's put that in the graph. 4 is the x-intercept. Let's try the y-intercept now. I'm going to plug in 0 for x. Okay, all right. don't combine those into 7 yet. You want to first do that log in your calculator. 3 is not inside the log. Okay, so let's put that log in our calculator. I'm going to put it in as log of 4 over log of 0.5 using change of base, so that's -2. And then that's going to come out to 1, so my y-intercept is 1, and it is going to fit with a decay curve, right? So something like that, and again, you could always find more xy pairs if you wanted to be extra sure of the shape or get a better idea of the shape. Okay, and that's it for transformations of these functions, and I'll see you next time.